So welcome everyone to the first Tezos Vienna Meetup. Nice of you to come here. Quite a nice turnout, I like it. We have some budget on the drinks and there's some finger food as well if you'd like. And we'll start by the first presentation, which will be done by me. We will be talking about smart contracts in ReasonML. And then we'll continue by a presentation done by Pietro, who is sitting here. And then we'll take a short break and we'll continue by 2 more talks. So if you don't have any questions or if you have your drinks and you're settled, we can start. So my name is Matej. I'm working with a company called Labs. We are focusing on tooling and education on Tezos blockchain. And today we'll talk about how you can implement a smart contract which stores a single number, a single integer on the Tezos blockchain using ReasonML programming language. So let's get started. The links that you see at the bottom, the first is my Twitter handle, the second is my Telegram handle, the third is our company Telegram group chat, and the fourth is the link to this presentation. So let's get started. First, a bit of history about Tezos. So how many of you are familiar with Tezos or blockchain in general? Can you give me a show of hands? Okay, cool. So, and those that are familiar with Tezos, can you raise your hands? Okay, cool. That's fair enough. So Tezos as an idea was published in 2014 in the form of the white paper. The ICO ended up raising over 200 million in form of crypto. Then the mainnet was launched in late 2018. I think it was somewhere in September. The most interesting feature, at least for me, is that it's implemented in OCaml, which I really like. And other nice features are that Tezos itself is self-amendable. So that means that to implement new features into the protocol, you don't need to create a hard fork like you did, for example, with Ethereum Classic or Bitcoin Cash or other blockchain forks. Another difference, for example, comparing to Ethereum, is that Tezos runs with a proof-of-stake consensus algorithm, which means that you don't need to burn a lot of electricity to have miners, etc. So you just have a stake and you bake blocks as a baker. Another nice thing about Tezos and the ecosystem is that we have very active foundations and the ICO funds are distributed in an even way to the ecosystem. So in terms of smart contracts, how many of you have ever written a smart contract before? Just give me a hand. Okay, cool. What sort of languages did you use? Did you use Ethereum, Solidity, or was it on Tezos? Okay. So on Tezos, if you want to write smart contracts and you want to go, let's say, pure and native, you will use a language called Michelson. Michelson is a stack-based assembly-like language that allows you to write really, really type-safe contracts. And it's also functional, so it's really nice to write. That also means that for beginners, it's harder to pick up. It was also hard to pick up for me. So that's why I reached for, let's say, alternatives. For example, languages such as Liquidity, Morley, LIGO, or Phi. And those are languages built on top of Michelson. You could think about it like TypeScript to JavaScript, CoffeeScript to TypeScript, etc. So, for example, Liquidity is the language that we'll be using today, and it's a language that compiles to Michelson so that you can deploy it on Tezos blockchain. So let's move on. Liquidity as a language is developed in France by a company called OCaml Pro. This company is also behind the, let's say, the most famous block explorer on Tezos, which is called EasyScan. It also supports both OCaml and ReasonML syntaxes. ReasonML support was added fairly recently. I can say that I was part of it, sort of. Open the issue on GitHub if that counts. There are subtle differences between pure OCaml and ReasonML and what Liquidity uses. Liquidity is effectively a fork of the OCaml or ReasonML interpreter or lexer, and it introduces, like, for example, new keywords or literals. So you have new types like address, contract, TZ for different units, etc. A typical Liquidity contract always has storage and has entry points. What that means, if you compare it to, let's say, Ethereum and Solidity, you also have entry points and you also have storage. So it's pretty similar, you could say. Liquidity also provides us with a CLI, which allows us to compile, deploy, test, and play around with the language itself. What we'll be doing today, we'll implement a simple smart contract with an interactive demo at the end that stores a single number on the blockchain called a counter and has one endpoint, a single endpoint, to increment that number by a given parameter. So let's get to it. This is how the contract looks like. Can you see it well in the back as well? So going from the top, we first have to define the version of the language that we are using. Currently, the example is a bit outdated, so it's a version 0.4. The latest version is, I believe, 0.9, and we are going towards, let's say, a beta release or a full release, so 1.0. Then we define the type of the storage we want to store on the blockchain. So in this contract, we'll only store one number, which is an integer. So that's the line number 3, right? And then we'll define the initial value for the storage. So when we deploy our contract for the first time, the storage of the contract will equal 0. So that means you can choose a different number, so the contract would start from, let's say, 5, 10, 12, or whatever, but we are starting from 0. Then, as I mentioned before, each contract has entry points, and this contract has a single entry point called increment. What it does, it accepts a single parameter, which is also an integer, which means that we can increment the storage by that given integer. And it also receives the storage, the current storage of the contract as an argument. What the body of our entry point does, it returns an array of operations that we want to apply on the blockchain in forms of transactions, which in our case is an empty array, because we are not applying any additional operations. We are just updating the storage by summing up the current storage and the received parameter. Then I have a couple of comments, a couple of shell scripts that I've written just to help us deploy and invoke the contract. So we'll just hop straight to the demo. We'll take a look at the code again. We'll deploy the contract, take a look at the Block Explorer, how it looks like, what's the address of the contract, and then we'll call it and see the storage. So moving on to my Visual Studio Code, you should be able to see it just fine. So again, we have the contract on the top left, and what we're going to do first, we are going to deploy it, and we are going to deploy it by forging a deployment operation that is signed by one of our wallets, and then we'll take a look at the Block Explorer, which we have running in Google Chrome, to see if the contract is there. So looking at Tezos, if you can see it just fine, right? We'll take a look at the current blockchain, right? So we are using a sandbox environment, which is provided by Matej as a way to implement contracts in a isolated way. So we have a pretty pristine blockchain. We are at block number 1, so nobody else is interfering with us. And we can take a look at the current deployed contracts, which are none, basically, right? So we have 0 contracts deployed currently on this blockchain. So we'll go back and we will deploy our contract, which is the counter contract. We have a couple shell scripts to help us out, so let's do it. Forge deploy, right? We take the signature and we inject it. Inject operation, contract deployment bytes. Yeah, so what I've just done, utilizing my shell scripts, I have deployed the contract by injecting the operation, and I've also mined a new block on the locally run blockchain. So now if we go back to Tezos, we will see a new block with the contract deployed. So we just refresh, and we see that out of nowhere, we finally have one contract. We see the address, we see who deployed it, and all the other parameters, and a balance as well of 10 Tezos, right? So what we're gonna do now is we're gonna take a look at the storage of the contract and see what the value is. It should be 0. Code. Here you can see, for example, the actual compiled Michelson compared to the liquidity we had before. So this is how compiled liquidity looks like in form of Michelson. If you wanted to write this by hand, I mean, feel free to, but some of us will prefer writing in a more high-level language. And going to the storage, it should be 0. So we see the storage, if I can zoom it in. Yeah. So it's 0, right? So the next step, the next logical step, would be to invoke or call our contract with the given entry point. So let's do that. We are back in Visual Studio Code, and we will use another shell script that I have prepared to call the contract, inject the operation, and increment the storage. So let's do that. Forge call. And of course, to call the contract, you need to know its address. So going back to TZScan, you can see the address of the contract on the top right corner. So we're going to copy that so we can call our contract. Copy that, right? Shell, and the argument that we want to provide for the call. So in our case, we are calling the contract that we have deployed previously, and we're passing in an argument 5. So that means that if the call is successful and we go back to the Block Explorer, the storage should be also 5 based on the code of the contract. So let's give it a shot. We copy the signature. There we go. There we go. So, all right, so the operation has been injected, and we also have a new block mined. So we should be at block number 3, if I'm correct, after the deployment and the call. So going back to TZScan, you can go to home. Yep, we are at block 3, because we had 2 transactions. We had the deployment, then the contract call, and we will go back to the contract, which is here, and we'll take a look at the storage. And the storage has increased to 5 based on the actual code of the contract. So that's it for the interactive demo. If you have any questions, I can pass out the mic and we can talk about it. So any questions? Maybe some hands? No? You have a question? Okay.
Anyway, I would like to increment
the storage by a different number, or?
Yeah, I would like to increment it maybe a couple of times in a single block.
Okay, then the shell script that I have injects the operation and then mines the block as well. So if you remove the mining part from the shell script that I have, you can inject a couple of operations. You can increment it by 5 several times, and then you can mine the block, and you would have all the transactions that call the contract in one block. So, but for the purpose of the demo and the shell script, it also bakes the block in the sandbox environment. So,
okay.
Yeah, so that's the reason. So if you want, I can call the contract again, just for the sake of sport. So let's see. So we forge call again. This time we can increment by, let's say, 10, right? We take the signature and we inject it. So we'll operation injected, block mined again. So we go back to TZScan, we refresh, and you see another operation here because it's another call. And you see the storage, and it should be 15, and it's 15. So it's actually working as expected, you could say. Was that all from your question?
Yeah.
Okay, fair enough. Any other questions, maybe? Okay, so you go first, I guess.
What does this actually compile to in the end? What does the mechanism compile to? What does it run the mechanism?
That's a bit more sophisticated question, and explaining this, I would run out of my depth. We can discuss this afterwards, probably with Pietro here, because he knows a lot more than I do.
It's an interpreter that is written in Common. It just interprets the piece of text that you give it to him. He types it, and then he runs it.
Was that enough as an answer? Okay, cool. And the next question?
Maybe you can explain the differences of a Tezos smart contract and Ethereum smart contract, and some of the properties where there are some differences.
Okay, I personally haven't written that much of Solidity myself, but I think the difference is in the underlying interpreter. So what you get, I mean, the main difference for me is if you deploy an Ethereum smart contract, you get a bunch of gibberish, while here you get an actual Michelson code that you can read, if you are proficient enough, of course. So I think, for me, that's the main difference. And of course, the underlying blockchain is completely different. So, but as I like to say, it's all electricity in the end. So maybe it doesn't matter in this case. So, any other questions, maybe? No? Yeah.
In the code, the storage, was it a variable name or is it some keyword?
The storage, so let me go back to the code. So the storage itself is a type. It's a ReasonML or a camel type. And then the initial value for the storage is a variable, let. So it's like a constant, you could say. So the initial value is a variable. The definition of the storage and how it looks like, the shape, is a type definition. So it could be an integer, which is in this case an integer, or it could be a record or any other of the OCaml types. So it could be a sophisticated data structure as well. At the end of my presentation, there's some links as well. And if you go to our website, stowe-labs.com, you'll see a Medium link where I've implemented a multi-sig smart contract where the storage is much more sophisticated than a simple integer. So that's a good example, I believe. So maybe I could just show you right here. So a couple of links if nobody has any more questions. The first one, our company, and then a couple more links. We have a Stack Exchange as well if you want to ask more questions, and some other links as well. So I believe that will be it. Thank you for listening.